Okay, so in this video, I will be going over the periodic table, the structure of it, and what an atom is, what an electron is, what a neutron is, what a proton is, all that fun stuff. So the first thing we need to recognize is how these atoms work. So every atom has a nuclei, and the nuclei is this little central thing right here. And the nuclei consists of neutrons and protons. So neutrons have no charge, and they're in the nuclei. And protons have a positive charge, and they're in nuclei. Now, these things on the outside, these are electrons. Now, electrons do not really have a mass. They have such a small mass that they aren't usually considered. I mean, sometimes they are. But they have a negative charge and they're out of the nuclei. Electrons are usually the things that are important in causing reactions and repulsions and all that fun stuff, and they kind of form a cloud. It's not really a large, it's not really an orbital structure. It's more like these things are going around and they're having their fun time, and they just kind of just exist near the nuclei, like that. This is just a very easy way of understanding it. So electrons, negative charge, and they are out of nuclei. Another thing to consider is that these atoms have masses. A atom with more neutrons and more protons is going to weigh a lot more than a atom with one proton, like hydrogen. Yeah. Okay, so periodic table. So first thing you should notice are these little boxes for each element. Let's talk about it. So at the is the atomic number, and the atomic number is basically the only way you can tell the difference between an atom. It tells you the amount of protons, and we discern elements by the amount of protons they have, and I guess the amount of electrons they have, as every element has the same amount of electrons and protons in their ground state. So, for example, boron has 5 protons. So, an atom with 5 protons is always going to be boron, as opposed to like an atom with 6 protons, which would be a carbon. Now, the next thing you'll see is the abbreviation. A lot of these are kind of simple and self-explanatory, like, I don't know, nickel and I. Makes sense, but some of them are a little weirder, like Hg. Oh, jeez. Hg and mercury. A lot of that is because of German names or Italian names or Latin names. I'm pretty sure you are expected to memorize a lot of these from their little abbreviation. So you should do that. The last thing that's usually on these periodic tables is the molar mass. We went over this in the last video, but molar mass is just the amount of protons and neutrons added together, as that makes up most of the mass of an atom. So you'll see that as you go farther and farther up and down, that you'll see more and more and more atoms and more neutrons adding to the molar mass. So if you compare hydrogen with a molar mass of 1 to astatine with a molar mass of around 210, we don't really know. We haven't really made a lot of astatines. It's pretty clear that the more protons and neutrons you have, the heavier it's going to get. So something to note before I go into the subcategories or the categories of these electrons, I mean not the electrons, of these atoms, is that there are 18 groups, so there are 18 columns basically. There are 18 rows, and there are 7 periods, or there are 7 rows. So I can organize this entire periodic table into metals, nonmetals, and noble gases and metalloids. Sorry. So what are these? Metals and non-metal. I mean, metals and metalloids take up pretty much a majority of this periodic table. They go up to here. So literally only these things are non-metals. Most of the periodic table is consisting of metals or non-metals. I mean metals or metalloids. So let's just go into the non-metals first. So non-metals are all of these. These have no metallic characteristics. They don't show anything. They have covalent bonding, like for example CO2. That's covalent bonding. Just remember that covalent bonding is just stuff that happens between fellow nonmetals, and they also are usually gases like carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. But usually they are gases. Now metals. Oh, also hydrogen is a nonmetal. Sorry, I forgot about him. And now for the noble gases. Noble gases are extremely non-reactive. Oh, and don't forget oganesson. Sorry. These are very non-reactive gases that they just exist. It's mostly because they have a full octet, or they just don't need to have chemical reactions to reach a stable state of being. Now we have the metals. So everything here is just considered straight metal. These are the alkali. Group 1 is alkali and group 2 is earth alkali. These are like the creme de la creme of metals. They have the highest metallic properties. They have the most ionic bonding. They have the most metallic bonding. They're very conductive. They're very prone to being electrocuted, I guess. And these metals are basically the main metals. Now these are the transition metals. These are actually probably a lot, like this group probably has the metals that you recognize the most. For example, titanium, chromium, iron, cobalt, nickel, copper, zinc, cadmium, silver, palladium, gold, and mercury. Now, these metals are kind of weird in the way that they work. They might bring you some confusion as you go further into AP chemistry. But just remember that these have metallic bonding, they can form ionic bonding, stuff like that. And then, oh, and also these are metals, my bad. Those are also transition metals. And then finally, we have our metalloids. Now, these are kind of the bad apples, or I guess the ugly twins of the metals. I don't know the proper wording, I guess, but these aren't really completely metals. They're kind of just a mixture of metallic and like non-metal characteristics. So you could see like silicone, arsenic, astatine. Those are the popular ones. They have some metallic properties, so some of them might be a little bit more malleable, some of them might be a bit more conductible. Right before you really get into it are what isotopes are. So isotopes are just members of the same element. So let's say you have hydrogen, right? You have hydrogen. Now hydrogen we know has one proton. And usually no neutrons. Usually. Now, as I said before, if you gave this hydrogen another proton, it would no longer be hydrogen. It would be a helium. It would have two protons. It would be a completely different element. But if you give this hydrogen a neutron, it will still be the same element, but it'll be kind of different. So that's what we consider isotopes. That's how we consider isotopes. So if you look at this little picture that I found on the internet, the most common isotope of hydrogen is protium, where it has 0 neutrons, like I said. and then deuterium, which has 1 proton, and then tritium, which has 2 neutrons. Now, you'll see that on the periodic table, let me get a quick screenshot. I'll just get the one for hydrogen. Oh, Jesus. Oh, okay. That's scary. You'll see that hydrogen has, I don't know if you can see that, has a mass of 1.008. Now, since there is 1 proton in the most common isotope, and the most common isotope will have a molar mass of 1. But since we have 0.008, we know that there's going to be some isotopes that are kind of common that has deuterium and tritium. Because deuterium has 2 things in the nucleus, therefore it's going to have a molar mass of 2. So that's where we kind of see these isotopes having an effect on your molar mass a little bit, as if you have an amount of hydrogen, there's a chance that some of it will have a neutron in it, and that's kind of something that you need to consider when doing chemistry. So yeah, that's what an isotope is. Alright, so last thing, ions. So ions are just charged atoms or molecules. So let's get hydrogen as an example. Hydrogen has 1 proton, and it's surrounded by 1 electron. So something becomes an something becomes an ion when the amount of electrons does not equal the amount of protons. So let's say H plus, or an ion of hydrogen, is going to just be a proton just existing, as it no longer has an electron. It will just have nothing in it. That is considered charged, or yeah. So, something that you should memorize is that a plus means that it is missing an electron, and a minus means that it doesn't have an electron. It has an extra electron. So H minus is going to have 2 electrons around it. And I know that's confusing. You imagine that plus means it has an extra one, but plus means that it has 1 missing, and minus means that it has 1 extra. So ions most often happen in elements or compounds that are unstable, or will become more stable, like they seek to become more stable by becoming an ion, or by reaching a more stable area, or a more stable state. For example, hydrogen wants to have 2 or 0 electrons, as that is just the most stable thing that it wants. So then most often that you will see either an H plus ion or H minus ion if it's ever charged, I guess. So yeah, that's ions, and that's it for the video.